Okay, we're back for the second part of Boyle's Law, and this is where we're going to put it into application, okay? I promised you that we wouldn't be doing formulas for the sake of formulas or taking history lessons, so this is where we're going to apply it. Now, I have used an example in the book so that you could have it to reference, all right? So I worked it out of that book, and so this is what they gave us, okay? So they gave us a pneumatic system, the picture here, and basically what the problem has done is they have got an initial system and they've added some additional piping to it. Okay, so in other words, they've increased the volume of their system from the original. So we have an original system volume of 8,000 cubic inches of piping. Okay, and I suppose that probably includes the receiver as well. But the piping here is about 8,000 cubic inches, and they've added some additional piping here of 200 feet, 50 feet, and an additional 2 feet of 1-inch diameter pipe, okay? So what we've got to do is figure out how much additional volume that is, all right? And we have done the area and we've done volume, and so now we're going to pull all these together here to see what kind of impact it's going to have on our entire system, because if you look, we're looking at some spray lines here, some spray paint lines. And if we add another one, what's going to happen to it? Will our system handle it? What kind of impact will it have by adding that additional paint line? Okay, so we got to think about volume first. Okay, and we said from hydraulic lessons that area times the length gives us our volume. Okay, now the 1-inch pipe has a diameter of 1 inch, obviously. Okay, so to figure out that area, we have to square that. So 1 times 1 is 1. Okay, and we're squaring that. And then we multiply that by 0.7854. Okay, should be familiar with that too. So 1 times 0.7854 is 0.7854. We multiply it by 200 feet of length of pipe, and that gives us 157.08 cubic feet of volume. But we want cubic inches, okay, because, like we said, it gave us the volume in cubic inches. So in order to do that, we multiply it by 12, and that 200-foot leg of pipe is going to give us an additional 1,884 cubic inches, 1,885 roughly, cubic inches of additional volume. But we've got another piece of pipe 50 feet long and another one at 2 that we have to do the same thing for. So again, 1 times 1 squared is multiplied by 7,854 times 50 feet. That gives us 39.27 cubic feet of extra volume, but we want it in cubic inches, so we multiply it by 12, and we wind up with 471.24 cubic inches. Okay, and then finally we do the same thing. I'll run through this one more time for you. Our diameter of the pipe has not changed. It's 1 inch diameter, and we square that. 1 times 1 is 1. Multiply it by 0.7854. Then that comes out to be 0.7854. And then you multiply it by the 2 feet, and that gives us 1.57 cubic feet. But as I said in the previous 2 examples, we have to have cubic inches, so we're going to multiply it by 12. And that gives us 1,884. You add all of these up together, and we wind up that all these lengths of pipe that we've installed are going to give us an additional 2,375, leave rounded to that, cubic inches of volume. Okay? So we started out with 8,000 cubic inches. We added 2,375 with that length of pipe, those 3 lengths of pipe, and we now have a new cubic inch of total piping of 10,375 cubic inches. Now, for our formula's sake, we started out with 8,000. That's the volume we started out. That's the first volume we had, V sub 1. Okay. Now we ended up with our second volume of 10,375. That's the volume we had, that's the volume that we created. We went from volume 1 to volume 2, okay? Let's just kind of give you a little subscript annotation there. That's what we've got right now. So, the book also tells us, let's back up for a second, our new system total is 10,375 cubic inches of total piping, okay? And the book tells us that we had a starting pressure at 110 psi. Now, let me stop real quick. We're going to pretend to valve this piping off, okay? So that our compressor is not going to come up and start it up and resupply us with the proper amount of pressure. This is just going to valve this off so we can work our problem, okay? So we started with 110 psi, and we started with a volume of 8,000 cubic inches. But that additional piping gave us more volume, which is where we went to, of 10,375 cubic inches of volume. So we got three of the elements we need to figure this to figure out what's going to happen to our pressure. Okay, because that's what we're after. All right. So again, this is our formula for Boyle's law. I mean, you can work it this way, but this way is easier. Okay, make it linear. Okay, make it linear. Take this, put it over here on this side, and multiply it. And that way, this is gone, and you wind up with that. Okay, should be pretty familiar by now. All right. So now what we got to do? Let's plug these numbers in. Okay, but don't forget, got to convert to absolute values. All right. So let's start dropping some numbers in. P1 is 110 pounds per square inch gauge pressure. We've got to make it absolute. Simply add 14.7 and you're done. So we wind up with 124.7 for our P1. Okay. Then volume 1, that's what we started out with before we made our additions, before we added all this extra piping. Volume 1 was 8,000 square inches. Cubic inches. I'm sorry. This should not be square inches. It should be cubic inches. Okay. And so we're looking to see what our pressure is. Okay. That's what we're after, P2. All right. And then we have a volume, the second volume of 10,375 cubic inches, not square inches, cubic inches. That's my fault. Okay. So now we've got all of our variables plugged in, and we're looking for this one right here. All right. So how do we find that? Well, let's do some math first. Multiply these two right here, the 124.7 times 8,000, we wind up with 997,600. Okay, that's equal to P2 times 10,375. Now, we talked about how do we get rid of everything so that we get P2 all by itself. Well, we divide whatever's hanging out with P2, okay, and we have to divide both sides by that. So we divide both sides. We divide this side by 10,375. These cancel out. Take this number here, the 997,600 that we calculated earlier, divide it by 10,375 because you got to do to one side what you do to the other, okay? So do the math there, and we wind up with P2 all by itself with a pressure of 96.15 absolute pounds per square inch, okay? But my arrow's a little late, that's okay. All right, so this is what we wound up with, 96.15 as our absolute pressure that we wound up with. But we got to turn it into gauge pressure, which means we subtract 14.7, and that gives us a gauge pressure of 81.5. That is 81.5 is what we wound up with after we added that additional piping. This is Boyle's law, inversely proportional. Remember that? Okay. Well, let's look at it. We went from 8,000 cubic inches to 10,375 cubic inches. So we went up in volume. And our pressure was 110, but after our calculations, we've dropped pressure to 81.5 pounds per square inch gauge. So we've proven Boyle's law, and basically what that tells us is that, yes, we added volume to our, and we added this third line, but how did it impact our system? Well, it made our pressure drop, okay? So we've got to make sure that our compressor supplying to the pneumatic system can handle that much volume, okay, and continue to supply us with that much airflow and pressure behind it as well. So our pressure dropped as a result of the additional volume. So now you know why it would drop, okay? So there's Boyle's law for you right there. The others are going to go a lot faster because their formulas are very similar, as far as manipulating, turning them linear and things like that. So that's Boyle's law for you right there. If you have any trouble understanding this, just go back in the video, watch it again. Again, hope you're taking really good notes because you're going to need them. And keep working these. And if you got any problems, just give me a call or come see me in the lab, or you'll make an appointment. You can do it however you want to, and we'll go over it and make sure that you understand it. But this is how Boyle's law applies to something that we would actually use out in the field. Okay, so there you go. Shut this one down and come back and make sure you watch the next one, because I believe it's Mr. Charles that we're going to talk about, and he's got some fun and exciting things too. So hang on to your seats, and we'll see you during the next lecture. Thanks.